Beneath the rolling hills of Geneva, Switzerland, lies a machine that could either answer the universe's deepest questions or become the catalyst for something much darker. It's the Large Hadron Collider, an engineering masterpiece so powerful that it can recreate the moments right after the Big Bang. But what if, in our pursuit of knowledge, we're playing with forces that could spiral out of control? This isn't science fiction. It's happening right now, 574 feet underground. Inside the LHC, protons are being accelerated to near-light speed and smashed together with such force that the universe itself trembles, if only for a moment. The result? A window into the birth of the cosmos and perhaps a glimpse of our own future, if we survive to see it. Imagine a ring, 17 miles in circumference, buried under the Earth. Inside that ring are superconducting magnets colder than outer space, guiding particles around the track at speeds so fast, they complete 11,000 laps every second. It's like sending two bullets hurtling towards each other from opposite ends of a highway, but these bullets are moving at 99.999% the speed of light. When they collide, the energy released is enough to mimic the conditions of the early universe, the Big Bang itself. This is the Large Hadron Collider, or LHC, the most powerful particle accelerator ever built. It's not just a tool for physicists, it's humanity's most daring attempt to understand reality. By smashing protons together in these high-speed collisions, scientists at CERN are looking for answers to the most fundamental questions. What is the universe made of? How did it all begin? And more chillingly, what lies at the edge of our understanding? In 2012, the LHC gave us one of the most significant discoveries in modern science, the Higgs boson, or as it's sometimes called, the God particle. This elusive particle had been theorized for decades, but no one had ever seen it. Why was it so important? Think of the universe as a giant cosmic soup, where everything floats around freely, particles of light, atoms, everything. But without the Higgs field, none of these particles would have mass. It's the secret ingredient that gives structure to the universe. Without it, nothing would exist. Finding the Higgs boson was like finding the needle in a haystack, but it was more than just a discovery. It confirmed an essential part of the standard model of particle physics, our best theory of how the universe works. The standard model explains the forces of nature, like gravity and electromagnetism, but it leaves out some massive questions that the LHC was built to answer. But the quest for knowledge doesn't end there. The LHC isn't just about uncovering the known, it's about discovering the unknown. Dark matter, for example, is one of the greatest mysteries in the cosmos. We know it's out there. There's 5 times more dark matter in the universe than there is ordinary matter, but we can't see it. We can't touch it. We can't even detect it, at least not yet. The LHC could change that. By smashing protons together with unprecedented energy, the LHC might help us detect dark matter, potentially answering why galaxies don't fly apart or why the universe behaves the way it does. But as we push the limits of understanding, we must also ask, are we crossing into dangerous territory? This is where the story takes a darker turn. Brian Cox, a physicist and former CERN researcher, recently made waves by reminding the world that the LHC has the power to recreate the conditions of the Big Bang. But what if, in doing so, we unleash something catastrophic? Take the 1978 incident with Russian physicist Anatoly Bugorsky as a warning. While working on a particle accelerator in Russia, Bugorsky accidentally leaned into the path of a proton beam. It passed through his head, burning a hole straight through his skull, but miraculously, he survived. Yet this incident illustrates the immense, often uncontrollable power behind these machines. The risks go even further. Some physicists fear that the LHC could accidentally create miniature black holes. Imagine a small region of space where gravity is so intense that nothing, not even light, can escape. Theoretically, these black holes would evaporate in a fraction of a second, posing no real threat. But what if something unexpected happened? Could one grow, slowly swallowing everything around it, eventually consuming the Earth from the inside out? This fear isn't new. Stephen Hawking himself warned about the dangers of such experiments. Hawking proposed that if we push the Higgs boson to its limits in high-energy collisions, it could cause a catastrophic event known as vacuum decay. In simple terms, This would be like popping the fabric of space itself, triggering a collapse of the entire universe. Beyond black holes and vacuum decay, there's also the possibility that we might unleash new forms of matter, or worse, open a door to dimensions we barely understand. Sir Martin Rees, one of the world's leading cosmologists, warned about these dangers in his book, Our Final Century. He questioned whether particle collider experiments like those at CERN could inadvertently trigger an event that would unravel reality as we know it. And yet, despite these fears, scientists press forward. Why? Because the answers to these fundamental questions could unlock the secrets of the universe. Could dark matter hold the key to faster-than-light travel? Could understanding the Higgs field allow us to manipulate mass itself? The possibilities are tantalizing, but they come with immense risks. The LHC, with its colossal energies and unparalleled design, is a testament to human ingenuity. But it's also a symbol of our relentless curiosity, a curiosity that sometimes leads us into dangerous waters. We've always been explorers, pushing beyond the boundaries of what we know, often with little regard for the consequences. Think of it like a ship sailing into uncharted waters. The crew is driven by the promise of discovering new worlds, but they also know the ocean hides dangers they can't foresee, monsters lurking in the deep. The LHC is our ship, sailing into the depths of the unknown. And while we've mapped out most of the risks, there's always the chance we've missed something lurking just beyond the edge of our understanding. So, what's the price of discovery? Are we willing to risk everything for the sake of knowledge? The scientists at CERN argue that the odds of a disaster are astronomically low. The safeguards are in place, and the physics, they assure us, is sound. But even if the chance of catastrophe is 1 in a billion, are we willing to take that risk? As we continue to explore the universe at the most fundamental levels, the moral questions loom large. We are playing with forces that existed only in the first moments of creation. Forces that shaped the universe, but which could also destroy it. The Large Hadron Collider is not just a tool, it's a gateway to understanding the very fabric of reality. But as we stand on the brink of discoveries that could redefine our existence, we must also ask, are we prepared for what we might find on the other side? We're racing toward the future, and with each new discovery, we inch closer to the answers we've been seeking for millennia. But in our quest for knowledge, we must also face the possibility that some answers come with consequences we may not be ready to confront. The LHC represents the pinnacle of human achievement, but it's also a stark reminder of the fine line between brilliance and catastrophe. Are we pushing the boundaries of science, or the boundaries of reality itself? Despite the risks, the LHC continues its quest for one of the most elusive substances in the universe, dark matter. We know it's there, silently pulling the strings in the background, making up about 85% of the matter in the cosmos. Yet, we can't see it, we can't touch it, and so far, we've only been able to detect its effects. The LHC could be our best shot at capturing this ghostly substance. If scientists at CERN can produce dark matter particles, it would revolutionize our understanding of the universe, unlocking secrets that could change the course of human history. But finding dark matter won't be easy. It's like trying to catch shadows in a room full of light. Then there's the idea of extra dimensions, hidden layers of reality that exist beyond the 3 dimensions we're familiar with. Some theories suggest that when protons collide at unimaginable speeds inside the LHC, they could open up gateways to these hidden dimensions. While this may sound like pure science fiction, it's grounded in serious theoretical physics, including ideas from string theory. If the LHC does reveal evidence of extra dimensions, it could explain mysteries like the nature of gravity, or even offer clues to the existence of parallel universes. But with these discoveries could come unforeseen consequences. What if by probing these dimensions, we disrupt the fabric of space-time itself? As the LHC pushes forward, the tension between knowledge and fear becomes ever more palpable. On one hand, the potential discoveries, dark matter, new dimensions, or even a unified theory of everything, could propel humanity into a new era of scientific understanding. On the other hand, there's the unnerving possibility that we're meddling with forces we barely comprehend. It's a delicate balance, a race against time to unlock the universe's deepest secrets while avoiding the cosmic Pandora's box that could spell disaster. The LHC's greatest challenge isn't just achieving these breakthroughs, it's ensuring that, in our pursuit of knowledge, we don't inadvertently pull the thread that unravels the universe.